So I wanted to make a few comments on what I've been seeing as I've taken apart the second engine now. You saw the teardown of me doing the first engine, the 2015, that came in the side-by-side. And then I had been working kind of off camera to disassemble the second unit. And you know, with this one, the intent is that I was primarily going to use just the crankcase, but I wanted to pick and choose parts between the two to try to get the best parts out of either configuration. So on the right here, this is the new, the 2010 engine casing, mostly disassembled. And then on the left here, this is the 2010, and you can see the damage that had come from that blown out piston. One of the things that I noticed though, and so this is the Grizzly engine, this is actually the Viking engine, but they use the same part number for the crankcase. And I thought, well, you know, if they're the same part number, most of the bottom end should be the same. And I think generally speaking it is. One thing I noticed though is that the main drive line, this came out of the 2010 engine. It's got a little bit more fine-tooth teeth coming off of the transmission. And then this actual drive line is a little bit more narrow than what I'm seeing on the original Viking one. So I don't know if that's actually like a design change that came about from the progression through the years, or if because it's a Viking engine, they decided that it needed to have more torque. And so they went with a little bit more coarse teeth and a thicker shaft. So what I'm doing currently is I'm going through and I'm going to take the driveline out of the 2015 and stick it into the 2010 drive or the crankcase. Something else that I've been doing is I've already completed 2 of these, but the bearings that are inside of it on this 2015, they're a lot smoother. There's no slop to them. The 2010, they're a little bit, you can feel a little bit of roughness to them, and in some cases, this guy's actually a little bit bound up. So I'm going to be replacing the bearings with the 2015 set and putting them in the 2010 crankcase. Again, they're the same part number, so things should fit just fine. And then once I get this half of the crankcase put together, I'll move on and start working through the other half. This side's obviously a lot more involved. This side's got a little bit of damage on the crankshaft and things. But I'm going to see how this part compares with the one over here from the 2010. This one is all working. A little bit of surface rust that I think can be cleaned up easily. But again, I want to see if they're the same part number, or at least like form, fit, function the same, to determine which of the two to fit into the rebuilt engine. So I'll get that underway and take you guys along for the ride. So as I mentioned, one of the tasks that I've got at hand here is to replace the bearings in the 2010 crankcase with the bearings that are coming from the 2015 engine. In order to do this, I ended up buying one of these blind bearing pullers. And what essentially it is a set of fingers on the end of a slide hammer that when you tighten the fingers, they'll expand and grasp onto the back side of the bearing, so that when you're slamming it with the slide hammer, it'll eventually work itself out of the counterbore and the crankcase. So I've got the last of the 2 bearings from the 2015 engine removed. And in the upper left of this video is the 2010 engine that's been cleaned up and is waiting the new bearings. So what I like to do is I like to just double check that all of the counterbores are clean of any dirt or grime, and then I'll rinse off the bearings with some WD-40. To get the bearings placed into the counterbore, I try to find a socket that's approximately the same diameter as the bearing's outer raceway, which I can hammer gently on to push it down into the counterbore. Once the bearings are placed, I'll use some 10W40 or whatever the engine oil is for the particular build I'm doing, and then make sure that the bearings are lubed up well. As I've mentioned before, I'm taking apart both engines in parallel so that I can see where parts are taken out and where they must be replaced. What you see here is the removal of the pinion gear, the bearing housing from this main driven shaft of the 2015 engine. These shims are the horseshoe pieces of metal that I'm showing. And I'll get into those in a little bit more detail in the future. But as you're doing your own reconstruction, make sure that you keep track of them. The next item to be removed is this reverse switch. It's just a simple single leaded part that mounts at the top of the crankcase and senses when the reverse has been activated through the gear select. So we're looking at the rear of the 2015 crankcase. You can see all the damage right around the main crankshaft location. And I've just popped off the oil seal on the rear driven shaft. You have to take this oil seal off in order to expose the bearing retainer nut, which I'll take off shortly. The bearing retainer nut is a left-handed nut, so you have to spin it clockwise in order to loosen it. I didn't have a real tool to do this, so I actually had to quick fabricate something with an old tool I had lying around and my angle grinder. It's a little redneck, but it seems to do the job. But essentially, it's a set of adjustable jaws that have a single tooth cut into them that interface with the cutout in the bearing retainer nut. It seemed to work all right, actually, though it took a little bit of finagling to get it to line up properly. To get the rest of the driven shaft out, though, it wasn't much more than tapping on the far end of it to push the bearing out of place where you had just removed the bearing retainer nut. Just to recap on what we've been doing here, this is the 2010 crankcase that's been cleaned up. I've placed the 2015 engine's bearings into this crankcase, and I'm about to insert the driven shaft from the 2015, or the original Yamaha Viking engine, into this Yamaha Grizzly crankcase. In order to set the driven shaft into the crankcase, I have to push these bearings down into the counterbore. And like I had been doing with the other bearings, I'm going to use a socket that's approximately the same diameter to tap it into the place. Not to belabor it, but this is essentially the same assembly process, just in reverse. So with the driven shaft in place, I've put the bearing retainer nut in. I'll follow that up with the oil seal, and then we'll put some thread lock on the ends of this before we put on the rear driven shaft yoke. Alright, I thought we'd take a breather here so that I can quick talk about some of the things I've come across as I'm starting to reassemble the engine halves. Got the whole new 2010 crankshaft crankcase put together, cleaned up and everything. I have the bearings placed in it on the inside. Some of these were blind bearings, so I had to use a blind bearing puller to pop those out. We have the first half of the driven shaft installed. I repaired this oil gasket, made sure that the form and fit was correct, and pushed that in along with the bearing retainer nut. Something to mention: the bearing retainer nut's actually left-handed threaded, so to tighten it, you turn left-handed. Conversely, though, this last nut inside the spline is standard, so it's right-hand threaded, and you'll tighten it right-handed. As we're putting it together, though, this front pinion gear comes with shims that make sure that when this is all inside the crankcase housing, that this mesh of gear will align properly with the driven shaft, which is up here. I haven't taken this off the old engine, but we'll want to make sure that the timing of those is correct to ensure that the wear on the gears isn't too significant during use. To do that, the technical service manual has a few pages in here where it talks about how to actually select shim sizes for things. And that's based on not only stampings that are on the crankcases. Sorry, I know that's difficult to see. But there's stampings on the crankcases. Oops, sorry. Guess that was this side. So in my case, that reads 64.98 for one of the calculations and 8.12 for the other calculation. And what you'll have to do is you have to come up with a set of shims that'll work to elevate this gear with respect to the position of this guy in the forward and back direction. So what I've come up with is through that series of calculations, and some of those are actually come from the factory handwritten, like this has got negative 0.12 on that housing, and then this gear's got a plus 11, or that's plus 0.11 millimeters. So through this whole calculation, I come up with 1.41 millimeters of shimming is what's needed. In freedom units, that's 056,000. And since I've got a Starrett gauge, that's what I'm going with, is with inches. In the other case then, when I put this driven shaft pinion gear back in place, I have to tune it up to 036 thousandths. And so that'll be through a combination of these sets of shims. These are from both engines, so I think I've got enough here that I can piece together a combination that turns out to be 036. And then once I get further into this engine, I'll have to remember my 056 thousandths to make sure that this gets elevated properly. So something to keep in mind. I mean, the crankcase, obviously, it's the same part number, but you've got different combinations of gears now. And it appears that each of the gears gets measured at, or each of the assemblies get measured at the factory to ensure, quality conformance and everything. So we'll get these put back together and keep filming. One of the recommendations from the technical service manual was to apply some lithium grease to the interior driven shaft splines, and that's what you can see me doing here. When I put this pinion gear and bearing assembly into the crankcase, it's somewhat of a snug fit due to the O-ring that's around the perimeter of it, but once you get it in place, you can pretty easily place your combination of shims to ensure the correct timing of the gears, as I mentioned earlier. With everything in place, I usually use my impact driver just to run screws in quickly. I'll turn then to my torque wrench, and for this pinion gear set, I think this was an 18 foot-pound torque setting for these 4 screws. The next set of items to come off of the 2015 engine are the oil pump, which you see me removing there, and then we're turning the engine around to get to the transmission side of things. First is the middle driven gear set with the splines that interface with the other side of the engine, the other side of the crankcase you already finished. And then this is the gear select cover housing and the gear select lever mechanism. Alright, I just wanted to give you a quick status on where things are for this build. I've got the 2010 crankcase cleaned up. I've pressed in 4 of the bearings that came with the 2015 engine. I'm going to start reassembling things with the components that came out of the 2015 engine. The one part that I'm going to reuse from the 2010 is the crankshaft assembly. So this was a part that I checked. It's got the same part number, and holding them up side by side, they appear to be the same part. So I'm pretty confident I can reuse that part as is. However, the balancer that goes with them is different between the Grizzly engine, the 2010, and the 2015. So this is the 2010. This is the 2015. It's approximately 110 grams different in weight. And so I think I'm going to stick with the 2015 component for that as well. I do have the transmission and everything out of it. and these are the old bearings from the 2010. So I just cleaned up the oil pump, and I'll be putting that back in first, and then we'll start to kind of piece things back in. I know that I have to press in this full piston, or sorry, this whole crankshaft assembly. As an assembly, it's got a press fit bearing that fits into this main counter bore on the crankcase. So I'll probably start with that because I know that with the tools I have available, that's probably just going to be pressed in place with a hammer. And I don't want to upset everything else after the fact. So I'll get underway, I'll film that and take you guys along for it. One of the things I found kind of difficult was getting access to the bearing that's attached to the crankshaft. You need to press this crankshaft into the crankcase, and what I found is that the recesses of the weight of the crankshaft, you could access the perimeter of the crankshaft bearing, and using a long rod and a hammer you could press it into place. In doing so, though, you need to make sure that the connecting rod doesn't interfere with the flange of the crankcase, because it is possible to pinch that as you're hammering it down. Just like you disassembled it then, just do everything in reverse with the parts that you're using. In my case, this is the oil pump that I'll be pressing in with a new set of gaskets that I had gotten for the engine. The transmission assembly is another one that's kind of difficult, not because it's technically confusing, but just because it's a lot to hold on to as you're pressing things into the bearings, and then there's a few counter bores in the crankcase that everything must align to. This is one of those instances where having a technical service manual on hand, and in my case printed out, is very useful so that you can reference the gears and the order in which they're meant to go into the crankcase. Even though I had disassembled things not too many minutes prior, it's still easy to get them confused when you've got all these parts laying around on the workbench. At this point in the assembly, I'm placing the middle driven gear down into the bottom half of this crankcase, where it interfaces with the transmission gears that are already in place. This middle driven gear is one of those ones that I had mentioned earlier that need to have the correct shims in place to ensure timing with the driven gear set and the splined teeth of the opposing gear. I was lucky enough to find, though, that when I measured the shims that were in place, they measured as 54 thousandths of an inch. And I think my hand calculations were 56 thousandths, so 2 thousandths of an inch is probably within the margin of error for my measuring style and the tools I have on hand. This middle driven gear is held in place with 4 screws, and the technical service manual says to put some Loctite on them. Not only that, though, they're meant to be torqued as well, which you see me doing after running them into place. Last but not least is the balancer for the crankshaft. As I mentioned earlier, this is the 2015 balancer that I'm using because I did notice a pretty drastic difference between the Viking and Grizzly engine sets. One other thing to mention, I guess, before I get going, the transmission on this, it's got 2 forward gears, a high and a low, a neutral, and then a reverse. So as I had this back together, when I had both shells put together, I had some loose screws holding everything together, so at least the seam was flush. One of the other checks I did was just to shift through the gears and make sure that things were spinning in an appropriate manner, forward or backwards and fast or spinner, going high and low speeds. I've had problems with that as I've put together John Deere engines in the past. Sometimes you'll get it all back together and it might spin, but you find that your gears aren't actually engaging properly, or that you're able to engage only a couple of the gears and not all of them. So something to keep in mind again, just because the glue up with the RTV sealant is it's kind of a messy thing, so you hate to have to pull it apart once you get it back together. All right, so here we are. We're about to the point where we're going to assemble both halves of the crankcase. I've got the one half already fully populated with all the transmission gears. And then I've got the other side, as you saw previously, I got that pre-assembled. So first I'm going to go around. I need to clean up this flanged face all around. I've already taken the old gasket material off. But what I like to do is I like to come in with a little bit of carb cleaner, something that's going to break down any of the oil on the surface, so that I can clean that up and apply a nice bead of RTV all the way around the perimeter. Now the way that this RTV cures is that they actually recommend that you put a bead on there all the way around continuously, assemble the parts together loosely, but then leave that to cure for about an hour or so before you actually torque it down to the OEM spec. And I think the point of that is just so that the vulcanization can take place and it'll harden a little bit rather than just fully squeeze out if you were to tighten it immediately. So I'm going to do that. I started to put together by batches of screws based on which side of the crankcase I'm working on. In some cases, some of the larger screws are ones that'll actually have Loctite. Those would be for like the engine mounts. The rest of them are just torqued to a spec. Now I admit I don't have a torque wrench that'll go below 10 foot-pounds. So I'm going to use those to just be hand-tight ones, whereas the ones that are like a 35 or greater than 20, I do have a tool for, so I'll use those as I can. So we'll get this set up. I'm always a little hesitant to start doing the glue up of these, just because, at that point it gets really messy to tear it apart. So previously I actually did do a check fit of everything, a dry fit. I made sure it all went together. Made sure that all of my gears rotate smoothly and nothing's being pinched in there once the two halves were together. And I'm glad I did do that because I had found that one of the bearings that I had press fit in was standing a little bit proud, and so it was actually preventing me from getting the nice smooth action. So I popped it apart, reset the bearing, and then reassembled a quick check fit that everything was smooth and there wasn't any kind of slop or anything in the system. So just something to keep in mind as you guys might be doing this yourself. I'll get this set up now though, and you guys can kind of see the process that I'm using to put this back together. At this point, I've got both crankcases cleaned. I've got RTV placed on the lower crankcase half, and I'm placing the upper crankcase half. It's a little bit of a snug fit. I had to gently tap it around with my rubber-headed mallet until I have both things seated together. As I mentioned before, you don't want to torque everything down at this point. You want the RTV to set up, but I am gently or loosely inserting most of the screws around the whole assembly. You'll see in the next series of clips, though, that these screws come from all different directions. They're different sizes. Some are inside internal cavities and some are around this perimeter. So the view shifts around a handful of different times as I'm inserting screws from different directions. But I'm still not tightening them down. I'll do that at a later point in about an hour from when the RTV was initially applied. All right, so we've got these two halves of the crankcase put together lightly. I haven't torqued anything down at this point per the RTV, the sealant vendor's data sheet. So I'm still waiting on this hour to come up with. I got about 15 more minutes to wait. But essentially, I'm getting antsy, so I ended up putting in the engine mounts. I've torqued those and got thread lock on them per the technical service manual. And I was just going through and verifying that I've got all of the different fasteners positioned around the perimeter of the crankcase like we're supposed to. You can see I've got a lot of squeeze out. That's good. And as I torque things down, I'm expecting more to squeeze out. This can always get cleaned up after the fact. So it's got a 24-hour full cure schedule on it. So sometime tomorrow we'd actually be able to fill it up with fluids and things. It doesn't keep us from continuing to assemble though. So once I do torque these two halves together, we can keep on building up on it. Um, the technical service manual doesn't have a whole lot of direction as far as like the crisscross pattern. So generally speaking, we're just going to be working one side to the other, top and bottom, trying to tighten everything uniformly. It's a little difficult because some of these are rather long and hidden in pockets underneath. So I'm going to try to do as much as I can from one end, probably actually the other side where more of the bolts are exposed. And I'll tighten those up and then come back to this side and tighten them up. It's 7.5 foot-pounds of torque, or 7.2 foot-pounds of torque on a lot of these small 8mm heads. There are some larger socket-headed screws down on the bottom side of this, and those are going to be 19 foot-pounds. Not a whole lot of torque is needed. I mean, it's an aluminum crankcase, so you don't want to strip things out. So we'll be doing that here just in a few minutes. At this point, the RTV has set up. It's been over an hour since I applied it, and I'm going around and now torquing everything, or at least ensuring that everything's properly tightened. You can see that I'm hitting it from different directions, and you have to go inside different cavities that are also on the exterior of the engine. I'll have to give it a little bit of a break here now, though. It needs 24 hours to fully cure, and I don't want to stress things by moving too fast on the reassembly of this engine. If you've made it this far, thanks for tagging along, and we'll catch you on the next one.